What happens if we explode an antimatter bomb on Earth? You might have noticed the title, Yes, we will use antimatter to blow stuff up. When it comes to something like this, I see a lot of excitement. However, before you begin watching this film, I would ask that you please stick to more peaceful purposes. So have you ever pondered if something more powerful and devastating than a nuclear weapon exists? It is true that antimatter's destructive potential is simply astounding. But how can you construct and detonate an antimatter bomb, and what are the ramifications of this? Hello and welcome to Zeey. In this video, we'll fulfill your sci-fi fantasies by discussing how to create and detonate an antimatter bomb, as well as the problems involved, and because we at Insane Curiosity care about peace, we'll discuss how antimatter might be useful and why you should too. Many people are perplexed by the concept of antimatter, and it is quite unusual. So before we go into utilizing them to annoy folks, let's define antimatter. Simply explained, antimatter is matter with its electric charge reversed. Paul Dirac proposed the theory of antimatter in 1928, and Carl Anderson discovered it in 1932, earning him the Nobel Prize. As a result, humanity recognized the positron, an electron replica having a positive charge. It may appear weird, but these particles, which are like mirror reflections of matter, actually exist. Positrons are produced by our sun's nuclear fusion as well as particle accelerators at CERN. When matter and antimatter collide, they annihilate one another, generating strong radiation and energy. Only half a gram of antimatter is required to make a warhead 40% more powerful than the bomb detonated on Hiroshima. The annihilation of 1 kilogram of antimatter produces 10 billion times the energy of 1 kilogram of TNT. This amount of antimatter would be enough to break the record set by the thermonuclear Tsar Bomba test on the island of Novaya Zemlya in 1961. But what about constructing an antimatter bomb? Because you must first construct it before you can use its enormous potential. Did you expect it to be simple? It appears simple, however, simply combine antimatter and matter, and then boom. We can already sense your enthusiasm when you heard about the boom. However, creating an antimatter bomb is not so simple. In truth, it is a very difficult task. Because antimatter does not rule our universe and we are all comprised of matter, we should be grateful. However, it is still present in trace amounts here and there. Even so, adds Rolf Langlois, a physicist at CERN. If you total up all the antimatter produced at CERN during the past 30 years, and if you were really charitable, you may receive 10 billionths of a gram. Even if it burst on your fingers, it's no more risky than lighting a match. In the episode Obsession of Star Trek, 1 ounce of antimatter reacting with matter is enough to blow out half the atmosphere of an Earth-sized planet. However, this is not the case. As previously said, antimatter is more devastating than normal explosives, but 1 ounce of antimatter is insufficient to create such devastation, and it isn't as dramatic as science fiction portrays it. As previously stated, antimatter is difficult to locate and produce, with production costs in the millions and billions of dollars. But for the purpose of argument, let us pretend that we have access to a sufficient amount of antimatter. The next issue we'll encounter is pollution. And in this instance, antimatter contamination would be disastrous for humanity because we couldn't utilize standard matter-made containers for it because they would annihilate each other. So, where are we going to put it? In a pinning trap, antimatter in the form of charged particles can be confined in an electric field. Just make sure the electricity is turned on. This type of trap makes use of the trapped particle's dipole moment. CERN scientists were able to maintain antihydrogen for around 17 minutes in 2011. The trap experiment at CERN now holds the record for antiparticle storage. Antiprotons were stored in a pinning trap for 405 days. This provides you enough time to develop your bomb and inflict fury on Earth. As previously discussed, you now have an adequate amount of antimatter and the ability to contain it. It's time to live out your nasty sci-fi fantasies. So how much devastation will it cause? Unfortunately, we have a point of reference. The Tsar Bomba was the most powerful nuclear device ever built, with 60 megatons of energy comparable to 2,000 Hiroshima explosions. This bomb's devastation is equivalent to a 1.5 kilogram antimatter explosion. You might want to take a step back for this. Even aliens would wonder, who does this to their own planet? But what if you increase the amount of antimatter to, say, 10 kilograms? This amount of antimatter would wreak roughly the same havoc as the 2004 Indian Ocean earthquake, the epicenter of which was located off the northern coast of Sumatra in Indonesia and generated the biggest tsunami in modern history. This earthquake had a magnitude of roughly 9.2. Waves with a height of more than 15 meters were formed by the movement of lithospheric plates. The tsunami hit the coasts of Indonesia, Sri Lanka, and southern India. Thailand and several other countries have killed around 300,000 people. The shockwaves from this earthquake were so powerful that they traveled across the entire planet, and the islands surrounding the epicenter shifted tens of meters. The mass shift and massive energy release, equivalent to 480 megatons of TNT, slowed the Earth's rotating speed significantly, shortening our day by around 2.68 microseconds, according to theoretical models. An explosion of only 10 kilos of antimatter can produce a similar force. In practice, the development of an antimatter bomb is only irregular. Obtaining antiparticles is a time-consuming, difficult, and costly endeavor. The European Center for Nuclear Research, or CERN, creates and studies antiprotons using the Large Hadron Collider, a charged particle accelerator. According to CERN employee physicist Ralph, synthesis of 1 gram of antimatter with current technology would cost approximately $1,000 trillion, whereas the annual U.S. budget would only be enough to manufacture a few micrograms of antimatter. Another natural calamity, the largest known to us, was an asteroid larger than Mount Everest that killed off dinosaurs 65 million years ago. If you want to see an apocalypse, blast 2.5 kilotons of antimatter, which will discharge energy equivalent to 100,000 megatons of TNT and will cause the commencement of a new ice age. The hot debris from the hit soared high into the atmosphere and beyond, heating the air to the temperature of the inside of an oven. A vast amount of dust dropped into the atmosphere, blocking the Earth's surface from the sun for several years, triggering a nuclear winter and killing approximately 0% of all life on Earth. Such is antimatter's might. The University of Michigan has developed a useful antimatter gun. However, despite the fact that it is referred to as a gun, it is not a firearm. It is, in fact, a small positron creator. Instead of using CERN's massive particle accelerator to generate positrons, this gadget can generate and spew short bursts of positrons. The University of Michigan team created a device less than a meter long that creates both short bursts of electrons and positrons, building on the work of researchers at the University of Texas. Despite the fact that the emissions endure only 30 femtoseconds, they emit quadrillions of positrons. This figure is comparable to those generated at CERN. You cannot damage your coworkers with the emissions from these guns. However, the emissions are strikingly similar to those found in jet streams from black holes and pulsars. Questions concerning the energy composition and how particles and streams interact with outside environments can be solved by researching how the device functions. But, as we stated from the outset, let us limit ourselves to more peaceful applications. So, what better way to use antimatter than as a fuel? NASA is interested because antimatter has the potential to be the ultimate rocket fuel. Antimatter is also a fantastically efficient fuel. Because 100% of the mass of the substance and antimatter is transformed to energy, an antimatter engine would be the most efficient ever produced. The current estimate is that antimatter may transport us to Mars in 6 weeks, as projected by the Penn State design team. The advantages of using this as a fuel are enormous. With a very small amount of antimatter, we can start a nuclear reaction known as antimatter initiation microfusion. In theory, it may be used as spacecraft fuel as well as a superb catalyst for our explosive. Matter-antimatter annihilation produces the highest energy per unit mass of any known physics reaction. A spaceship powered by this approach would require as little as 1 microgram of antimatter, depending on the mission length. The procedure is really efficient. The energy released when matter and antimatter collide is approximately 10 billion times that of typical hydrogen and oxygen burning. The scientists at Penn State have devised an antimatter storage ring design. This design can be utilized to create modern-day spacecraft. The entire antimatter engine would be made up of a few components such as a magnetic feed system, a magnetic rocket nozzle thruster, and storage rings. The inability to synthesize antimatter in large quantities is the only barrier to the development of super-powerful weapons or fuel. People have only produced a negligible and insignificant dose for all of their efforts. This is just enough to boil a cup of coffee with 19 nanograms of antiparticles. However, if we can learn to collect additional antimatter from space, we will face a new challenge. If such technology gets into the hands of a terrorist organization, the ramifications for humanity might be disastrous. This opens up enormous possibilities for the future. And it will be fascinating to observe how we use technology and whether science triumphs peacefully or explodes in our faces. It's one thing to discuss this as a sci-fi fantasy, but what if we can harness the energy of antimatter? Will this one day harm us or become the most powerful energy catalyst for our evolution as a species? Please share your thoughts in the comments box below. Also, like and subscribe to our channel, as this encourages us to continue generating fantastic videos like this one for you.